you want to put your flat in the market for rent, and you are using a predictive model that predicts the price that you have to put on your flat. If there is an actual price and your model overestimates, so the cost might be remaining on market for a long time. So the actual is 600, the model is, so this is actual, the model is predicted it as 900, and probably no one is coming to take your flat because they check the price and they check the market and they see that the price is too high for this market and they do not come, and every month that they don't come, your flat would remain empty and it costs for you. Okay. What about the other way? So the other way is underestimating. Underestimating is when the actual is 600, your model is saying that the prediction is saying that it worth 400. In that case, the cost would be signing a bad contract. So you lose money over this contract because you have signed and you have let your flat under the market price. So those are two different costs, but the costs are not always financial. The costs are social, the costs are economical, environmental. These are different perspectives. Let's assume that we have a test, and the test is for once again COVID, okay, and illness. There are two different cases that our test can make mistake: false positive and false negative, two errors. And false positive is when our model falsely label someone as positive. So the person, the actual, is COVID free. Our model is said COVID. And what would be the cost? Well, unnecessarily lockdown, let's say, unnecessary isolation. But what about false negative? False negative is when our model falsely predicts the outcome as negative. So the actual is COVID. Our model says that the person is COVID free, and the cost is spreading the virus. So you can see that from the social point of view, from the health point of view, this is a very, very higher cost. Okay, it has higher cost from different perspectives. So you might want a model that it has this feature that the error of false negative is as low as possible. You don't care to put people who are healthy in lockdown. Okay, yeah, definitely it has an individual cost, but it's not it's not even close to the cost of letting people with COVID to freely roam in the society. So in that case, this one has much higher cost. This error has a much higher cost than the other error. Okay, so let's go through this slide. There is no universal cost, like always this error or that error is more costly. Different stakeholders have different preferences. Knowing your preference is very important, and based on knowing your preference, you can adjust predictive methods to avoid one type of error that is beyond our module, or choose a proper performance metric that reflects the error cost in order to select your model accordingly. So after evaluation of different costs for different types of errors, you might come with the idea that, okay, I want to minimize this error. And this is what I want you to understand. So I want you to understand that there are different costs for overestimation and underestimation, for false positive or false negative. And then I want you to understand that this information would help us for choosing the right model. And the last slide is just wrapping up everything together. So to wrap up, what is the cost of error? Well, there are different types of errors within regression and classification problems, and they incur different economical, social, environmental costs to different stakeholders. So for regression, we have overestimation and we have underestimation. For classification with binary outcome, we have false positive and false negative. False positive is when our model falsely label the case as positive, and false negative is when our model falsely label a case as negative. Why do the error costs matter? The importance of different error types are oftentimes not equal to us. Sometimes, as I explained, for instance, false negative is a more costly error to us. Okay, especially when it's about a disease. Another example is in a court. So you might either convict an innocent person or set free a guilty person. It is way more costly to convict an innocent person because it undermines the credibility of your judgmental and judicial system. So different errors have different costs, and these costs are not equal, and we want to choose a model or a method that minimizes one of these costs. Okay, in the expense of the other one, doesn't matter, but we want a model to minimize one of these costs. How to evaluate error costs? Well, from different perspectives, i.e. different stakeholders and different aspects, by organic thinking. So on that court system error, it's a philosophical question, can be supported by empirical evidence, but at the end we need organic thinking to figure out whether overestimation is worse or underestimation is worse, whether a false positive is worse or false negative is worse. When to consider error cost? Always. So anytime that you have a predictive modeling problem, you have to think about what are the types of errors and which one is more costlier to us. And that's all.